So I'm Coach Jones, and in this video I'm going to go over how the operations with functions. This is Unit 2, Section 6. Our objectives today are to add, subtract, multiply, and divide functions, and to write and evaluate composite functions. That is the new part. We've already done the add, subtract, multiply, and divide, so we're going to start with that. A composition of functions is our new vocabulary, and that's what we're going to learn today. That's the new thing that we're going to learn today. So obviously you can perform operations on functions in much the same way that you perform operations on numbers or expressions. So you can add, subtract, multiply, or divide functions by operating on their rules. Okay, so basically here we have addition, subtraction, multiplication, and division. So these are just with functions. We've got a function f of x and a function f of g of x. We're going to add those functions, subtract them, multiply them, or divide them. Okay. So what I want you guys to do right now is pause the video, go ahead and do this problem, add these two functions together, and then come back to me when you're done. Okay, so for this, I'm going to use my vertical method, 4x squared plus 3x minus 1, and we're going to add to it 6x plus 2. We're adding like terms, so obviously we drop down the 4x squared, we add the 3 to the 3x to the 6x, that gives us 9x, and 2 minus 1 is 1. Our next one is subtraction. So on this one, again, it says we're going to subtract f from g of x. So we're going to take this function and we're going to subtract from it the 6x plus 2. So once again, pause the video, go ahead and do this, and then come back to me when you're done. So here again, f of x minus g of x. So we are going to subtract the 6x plus 2 from the 4x squared plus 3x minus 1. And when I taught my students this, I showed them this, subtract this, change these two signs, right? Then make this a plus sign. Then we're combining like terms again. The 4x squared drops down. If we subtract 6x from 3x, we get negative 3x. And if we subtract 2 from negative 1, we get negative 3. All right, so this next one is multiplication. F next to g means multiplication. So we're going to multiply f of x, which is 6x squared minus x minus 12, to g of x, which is 2x minus 3. So the way I taught my students to do this is with the box. So we're going to do the box method here. So we're going to actually put the 6x squared minus x minus 12 on top. And we're going to put our 2x minus 3 over here. So once again, pause, work this problem, and then come back to me when you're done. So here when we multiply the 6x squared times the 2x, we get 12x to the third. When we multiply the 2x times the negative x, we get negative 2x. When we multiply the 6x squared times the negative 3, we get negative 18x squared. When we multiply the negative x times the negative 3, we get positive 3x. And again, that's a very common error, y'all. So anytime you multiply two negatives together, make sure that you take into account that you're going to get a positive. Then we're going to multiply the negative 12 times the 2x. That's going to give us negative 24x. And then we're going to multiply the negative 3 times the negative 12. That's going to give us a positive 36. I want you guys to notice these like terms here. We've got negative 18x squared and negative 2x squared. Those can be combined. We've got the 3x and the negative 24x. Those can be combined. And remember, I told my students that where there's diagonals, you're going to have like terms. So now all we're doing is combining like terms to get our final answer. All right, the next one is division. So we've got f of x over g of x, right? So that's what we're going to do again. We're going to multiply, we're going to divide this 6x squared minus x minus 12 by 2x minus 3. So I'm just going to put those into long division. And if you guys recall, the way we do this is we take our 6x squared and we divide it by our 2x, right? So we're taking this and we're dividing it by this. That's going to give us 3x. We're going to put that 3x on top, right there. And then we're going to multiply that by our 2x minus 3. That's going to give us 6x minus 6x squared minus 6x. Sorry, minus 9x. Sorry, y'all. We're going to put this down under here. And we're going to subtract it. So that's going to make that negative and that positive. So then we're going to combine our like terms. And that's going to give us our 8x minus 12 because we're bringing down the 12. So now we're going to take the 8x and divide it by 2x. That gives us 4. That's where this 4 came from, is from what we just did. So then again, we're going to multiply that by our 2x minus 3. When we do that, we get 8x minus 12. Well, that is exactly what we had under there already. So when we subtract that, sorry, that is so ugly, y'all. I got to fix that. 8x minus 12. There we go. So we're going to then put that down under here. Going to subtract it again. Well, obviously that's what's already there, so it's going to cancel out the whole thing, so we had a remainder of 0. So our answer is 3x plus 4. Got one more I want to show y'all. Now this one was not in the notes, but I want to go ahead and show it to you anyway. So on this one, we're just going to basically take, again, the f of x and put it on top and the g of x and put it on the bottom. Well, in this particular problem, there is no more simplification that we can do. So we're going to leave it just exactly like that. So it's really important that you guys realize when we can't simplify, we won't. We'll just leave it as the rational expression. So another function operation uses the output from the one function as the input for the second function. So this operation is called the composition of functions. So what we're going to do is we're going to find an answer to one function, and then we're going to put that answer in to the next function for the x's, okay? So composition of functions, f of g is noted f of g of x, or f of g of x, you can see it in the parentheses, okay? So when we talk about this, the composition of f of g of x or f of g of x is read f of g of x, just like we can see here. We need to be careful though, because sometimes you're going to see it like this, and this means multiplication, right? But that's a solid dot, whereas if you have a hollow dot, that's a composition. So be really careful when you guys are looking at your notation so you'll know what's happening. Are we doing multiplication or are we doing a composition? So here we go. We're going to go over this. This is now evaluating a composite function, okay? So when we're doing these, we're going to work from the inside to the outside, okay, with these. When you have a number, we're working from the inside to the outside, okay, when you have a number. So we're going to work with this one first. So that is this equation, right, y'all? So we're going to say g of x equals 7 minus x. Now, we're actually solving for g of 4. So we're going to put that 4 in for that x. 7 minus 4, that equals 3. Now, here's the key. We're going to take this 3 and we're going to put it in the next function. So our next function is this one, right? So f of x equals 2 to the x power. So we're going to take this 3 and put it right there. So we're going to say f of 3 equals 2 to the third. 2 times 2 is 4 times another 2 is 8. So that's 8. So our answer for f of g of 4 is 8. So we took the output here and we made it the input in the next function, working from the inside to the outside. Okay? Going on to the next one. This one again, we're going to work from the inside to the out. So we got our f of 4 here. So we're going to go f of x equals 2 to the x power. So f of 4 equals 2 to the 4th power. That's 16. Then we're going to take this and we're going to make it the input for the next one, right? So then we got our g of x equals 7 minus x. So we're going to go g of 16. Sorry. So that's going to be 7 minus 16, which is 9. Sorry, negative 9. So our g of f of 4 is negative 9. Next question. This one, are the u-tries. So I would like you guys to do these and then come back to me. So on this one, again, inside to out, right? So g. So we're going to say g of 3 is equal to 3 squared, right? Now track it with me here. 3 squared, so that's 9. Then we're going to do f of 9, right? Again, taking that and putting it in there. So that's going to be 2 times 9 minus 3. That's 18 minus 3, so that's 15. So f of g of 3 equals 15. Do the next one and then come back to me on it. Pause and then come back. F of 3 is equal to 2 times 3 minus 3. That's 6 minus 3, which is 3. Then we're going to do G of 3, which is going to be 3 squared, which is 9. So here we go. Again, G of F of 3 is equal to 9. So also, we're going to use some graphs. So we're going to take the output from our first function and we're going to put it in as the input in our next function. So let's see how this works. So we've got our G of 2 here, right? So G of 2, so I'm going to do this with a different color so y'all can see it. So when I do an input of 2 here for G, what do I get out? I'm looking on the graph, a 2. Do y'all see that? So my input is 2, my output is 2. So input is the x values. That's my x-axis, right? There's my output, right? So now I'm going to take that input that output that we just had, and we're going to now look at the f of x graph. So this is going to be f, and we're going to take this and put it in there to the 2, right? So when we do this one, when we're looking at f, we look at 2 here, we go down to the f of x graph, and you see it intersects right there, and there's our y value, -3. So that is our answer. Here's this next one. So we got our h graph, which is red. So that's h of -2. So once again, we're going to find the x value, -2 right there. We're going to go up. That's where it intersects the graph. And so our value is 1, right? That's the y value. We're going to take that output 1 and we're going to put it now in the g of x graph. So we're going to say g of 1. So we're going to look for the x input of 1 right here. And notice that that's at 0. All right, let's see if you guys can do these next 2 on your own. Come back to me when you're done. So with the f of -2, so we got f of -2. So I got my -2 right there. Go down to my graph. It intersects at -3, doesn't it? So again, remember that output is going to be the input for the next one. So we got our h graph, right? So h of -3. So -3 is right here. Go up there and intersect that graph, and that is, our y value there is 2. Okay? For our next one, we're looking at g of 3. So our g graph again, g of 3. So at 3, what do we have? Again, we have 0, don't we? Y'all see that? That's our 0. So our output will be 0. And then we've got our f graph, right? So our f graph is the blue one. So when we put 0 in for f, what do we get out? We put 0 in for f, we get -1 out. Okay? These are some that you probably need to practice, guys, because there's going to be a question like this on the test, and you probably need to make sure you understand these pretty clearly. And if not, ask me a question in class. All right, so the next thing we're going to do is we're actually going to write composition functions using just equations, okay? So now with these, we're going to work from the outside in. The others we work from the inside out, but these we're going to work with the outside in. See, we got this f of x right here. So we're going to say 3, and we're going to put a parenthesis where the x goes because we're actually going to put this equation in for that x right there, okay? So we're going to just put an x where that goes, and we're going to put a -5. So I'm going to go ahead and put this 4 over x plus 2. So when I do this, I just know that 3 over 1 is the same as 3. So we're going to multiply across the top. That's going to be 12 over x plus 2 minus 5. We cannot simplify this anymore. Some we will be able to, this one we can't. So on example 5b, this time we're going to take the 4 and we're going to put, again, parentheses where the x would have been, plus 2. We're going to take this equation and we're going to put it in for that x. So we're going to put the 3x minus 5 here. The only thing we can combine here are the negative 5 and the 2. So this is going to be 4 over 3x minus 3. Again, this is g of f of x. Okay, so we're going to do the next 2 examples. I'd like you guys to do them and then come back to me when you're done. So this one, again, what are we doing? We're going to put the x squared plus 2 in for the x in the 3x. So we're going to pause, go ahead, do that, and then come back to me. Okay, so here we're going to distribute this 3 to both terms. So this can be 3 square root of x plus 6 minus 4. We can combine these 2 terms because they're like terms. So that's 3 square root of x plus 2. That's f of g of x. Last one. Maybe this one. Yeah, so here again, we've got the square root, right, plus 2. So we're going to put this in for that square root. So that's 3x minus 4. So this can't be simplified anymore because of the radical. They got to be like terms, and just have to have 2 things under a radical for them to be like terms. So this is g of f of x. It's that simple.